hi everyone. I'm going to talk about unit testing on iOS and show you why you don't need to be a Voodoo priest to use tests to your advantage. First, a few words about myself. My name is Tim. I'm an iOS developer from Düsseldorf. Like you just heard, I co-founded Rheinfabrik recently. And before we get started with unit testing in particular, I'd like to show you different types of tests, as well as reasons why you should care about them at all. So, the first type of test I'd like to show you is called integration tests. Integration tests verify that different parts of your app work together as expected. So, for example, you could test that a button on your view, when you push it, shows the next view controller correctly, as well as you get the correct content. Like a very default test case is you got a list of 100 items, and it's sorted alphabetically, and you check that when you tap an apple, on the next screen you see that an apple is green, whatever. They also test that your whole system integrates correctly with the production environment. For example, most of us write apps that talk to an API. So we need to verify that we talk to the API correctly and use the response from the API correctly. So another term that you might often hear is acceptance testing. On iOS, we tend to use those terms for similar things, but in general, acceptance tests describe tests that are focused on the use case. So integration tests focus on the integration of systems, while acceptance tests focuses on your project manager or customer accepting your product. And that's because an acceptance test is very easy to translate to a specification that you get. So the great thing about integration testing on iOS is that it sees the app in the same way that a user or tester would. So it is like a black box, and the integration test itself does not know anything about the architecture or classes or whatever is going on inside. It's just executing a series of touch events and verifying what it sees. Cool thing about it is that you can run it on the device, so you can show your boss and your coworkers what a good developer you are. If you want to know more about integration testing on iOS, you should check out two technologies that use a little different approaches. On the one hand, there's Frank. Frank uses the popular Cucumber syntax, which lets you use a lot of verbose, normal English language to specify the feature. It's very mature and feature-rich and has been used by the Ruby community for years. The bad part about it is that sophisticated gestures like dragging, long tapping, or shaking or whatever are very hard to do with Frank. On the other hand, we got UI automation, which is from Apple. It offers better support for complex gestures, but it's very hard to maintain for large projects. You just write individual test cases in JavaScript, and the big test pool can get messy pretty fast. There are a lot of other solutions available. Most of you have probably heard of KIF. You should check them out. Today, we're going to focus on unit tests. Unit tests, unlike integration tests, verify the result of the execution of a single method of a single class. So what does that mean? Most of the time, you write one class that tests everything that another class does. For every public method, some people also do private methods, but that's another discussion. We create one or multiple tests that verify that everything's working as expected. Everything that is outside of the tests of the class under test should be stubbed or mocked. I'll show you more about that in a few slides. Unit tests are designed to be very fast, so they can be run whenever you build your app. If your tests are slow, obviously you won't run them every time you build your app, and you don't test. So you don't need to do slow unit tests, then don't do unit tests. Okay, so how do we integrate unit tests into our daily workflow? There's a technique, most of you have heard about it, it's called test-driven development. I'll just do a quick recap. It relies heavily on 3 steps that are repeated over and over again. First, you write a failing unit test. Make sure it describes exactly what you expect the code to do. You may start with a happy case and then think about edge cases, unlikely scenarios, and even add tests for scenarios you don't want to happen, like nil parameters or whatever. Then you go and write the simplest code that makes the test passes. Very important part about it is you are absolutely encouraged to write bad, ugly code in this step. You don't need to make it happy, you just make the test pass and go on. Then the third phase is called refactoring. This is where you clean up the mess you made in the last step. You refactor as long as you want, you make the code pretty, you extract code, and after every change you just test your app again, and as long as it's green, you didn't break anything and can go on. So that sounds a lot of extra work to most of you, I think. Why do we even want to write tests at all? Because tests are for losers. I'm sure most of you are excellent developers, and as we know, excellent developers don't write bugs at all. So you don't need to do tests, right? Well, I've made a list, and it's called the top 5 reasons to do test-driven development. Reason number 1, rapid changes. We've all been there. We had to make a change in a very old and fragile part of the app, which was written by that douche who quit months ago and did not like documenting or testing things. Wouldn't it be great if there was a way to know that everything is working as expected after we're done tearing the class apart? Unit tests allow us to make changes to code quickly. Whenever we need to change something, we just modify the existing tests, if there are any, to reflect the new behavior, or we add new tests that verify that what we're doing works. Then all we need to do is get the tests working again, and we can move on to things that are more fun than old code. Even if the code did not have tests previously, we can do our best to write tests that reflect the current behavior. You can think of we just poke the current code and see what happens, which makes us better understand what's going on. So we don't have to code completely blindfolded. Another bonus is the next guy is going to have tests and won't hate us. So breaking one part of the app because you changed something in another part should be a thing of the past when you're doing test-driven development correctly. Reason number 2, knowing when to stop. So most of us are developers who love their code. It's never good enough. We're always optimizing, tweaking, trying to make it prettier, and just be the guy with the great code. So why else would so many hours go into discussions about code formatting or method naming or whatever we spend our brains on? When doing test-driven development, your tests give you the confidence that you've done enough for now so you can stop tweaking your code and move on to the next problem. I think a little tweaking is all right, so we don't want to write messy code. But at least test-driven development makes it very obvious that we might be over-engineering things. If the tests are green and we've done everything we wanted to do, so we don't need to spend another 6 hours optimizing the code, probably, until we made some really bad code. Next scenario, which should lead to better code, is our next reason. Reason number 3, understanding the design of your code. Most of the time we just start with the method name and start coding right away. And while we're coding, we imagine new scenarios that might happen, shift things around, move code around, and gain an understanding of the code while we're writing it. In test-driven development, we first specify exactly what we want the code to do. Like we describe what do we expect, and then we just write the code of it. The great thing is it separates the architectural decisions from the decisions about the code itself. As soon as we know what the code is going to do, we can worry about great architecture, method naming, whatever. Reason number 4, regression testing. This one is actually one of my favorites because it helps new people who don't do test-driven development yet understand why it's great. Imagine you got a bug that that just appeared. Yesterday you built reactive Cocoa into your sign-up flow, and you released the app, and today your music player is broken. You've got no idea why, but it's pretty critical, and you didn't test it because it's not in that part, right? So with regression testing, you write a test for the music player that's broken now, and by definition, by keeping the unit tests around, this bug will never occur again. So we still don't like what happened, but at least we're sure it won't happen again. And if we keep doing that, even if we're not doing test development daily, in the long run we'll have fewer bugs because we got rid of them for good. The last reason, happiness. Happiness is important, right? So we don't have a happy job every day. We've got big problems, long stories that might take days or weeks or whatever, and are very hard to do. So you don't get the great satisfaction of deploying a feature, like doing something your users immediately see. Test-driven development gives you the green light whenever you're doing a correct build. So at first you got a red light, you specify all your tests, and then you go into the second stage where you try to make your tests pass. This is where the fun begins, and you get the green light, and you're confident that your code is doing what you want. This confidence can be very important because yeah, when you deliver the story, you know it does exactly what you wanted it to do. And if your project manager is coming around and saying, that's not what I wanted, then you can say, okay, that's not what we specified. But you did your job correctly, and your code is working correctly. And yeah, I think a nice benefit is fewer bugs, which should make us happy, because fixing bugs is not fun at all. Yeah, and I think we just want to be happy. So now that you're hopefully interested in test-driven development, I'll show you something even cooler. It's called behavior-driven development. Behavior-driven development, or BDD, is an extension of test-driven development. However, instead of focusing on individual test cases, BDD focuses on the behavior of the class under test. This sounds a little bit artificial, but you'll see it in a second. You just specify a state that an object is in, and then you specify how it should behave for a certain event. Yeah, here's one of the big pros of it. BDD tests are very verbose. That's why they make great specifications. In this example, we can see the basic structure of a behavior-driven development specification for a class. First, we describe, this is the keyword describe, the class under test, which is, we're testing n as number here. Then we set it into a state. The state is, has been initialized with an integer value. The context block is just another keyword that allows us to wrap multiple test cases, which are identified by the it block, into a common state. The before each block gets executed before every test case, so we always start with the same state. So just by looking at this specification, everyone knows how n as number should behave. Maybe even someone who's not a developer. This way we get the executable specification, but we also get a living documentation, which I think is the only documentation we really want. Yeah, obviously this is a trivial example, but I'm sure you all have a class that might benefit from a living documentation. Next up is BDD leads or may lead to better architecture. So I think most of you can see themselves as the guy in the red shirt. We have all been there, made architectural mistakes, and thought, oh my gosh, what have I done? So let's see, we're writing a specification for a custom view with the text field. This would be a way to start with the specification. Most of the time, when we are writing the specification, we immediately realize that there might something be wrong. So, should our view really update the model object, or is there some kind of pattern that might go against that? Well, now that we found a mistake, we can rethink our architectural decisions and improve the app's architecture altogether. All right, let's talk about the tools you can use to write tests for your next iOS app. First tool, you might know it, it's Xcode. It comes with a testing framework called OC-Unit, and whenever you create a new project, you see the little checkbox, use unit tests, I think. It's very easy to run the tests whenever you do a build, and yeah, for test-driven development, it's great. However, if we want to do behavior-driven development, we need to put something on top of it, and that might be Kiwi. Kiwi allows us to write tests in behavior-driven development style, and it is built on top of OC-Unit. So whenever Apple is doing improvements on OC-Unit, or Zen testing kit makes progress, which OC-Unit is based on, we get that for free. Sadly, I think Apple doesn't care about unit testing at all. I'm not sure if anyone there uses it because there's little progress, it's hard to do a lot of hacking, and yeah, but in case they do, fingers crossed, we'll benefit from it. Apart from behavior-driven development syntax, it comes with a lot of other great features that can make your life easier when testing. Among them is mocks, stubs, matches, asynchronous helpers, and whatnot, but we'll look at them individually now. Even if you don't use Kiwi, I think the next techniques apply to everyone because it's handling common problems, like everyone's trying to test his asynchronous network calls. But the first one I want to talk about is mocks. Mock objects are objects that look like real objects but don't have their functionality. They are mostly used when the method under test has to interact with another object. As I said, unit tests are or should be very fast. And initializing objects can be very slow. If you're doing like thousands of test cases, it makes a difference. So a mock object is very lightweight, and we don't need to do the whole initialization cycle or state stuff of a real object. In this example, we just create a car mock. We configure it to behave like a car and say, okay, if you are asked for your weight, which is actually stubbing, which is in mocks very important, it will return the value 1,500. So if we test our garage, if it can calculate the total weight, we know that this car will return 1,500 no matter what. Next thing, as I told you, is stubs, which is kind of like mocks, but for real objects. It allows us to manipulate real objects, but get a deterministic state, so we are sure that what we're getting back. Stubs, you should use stubs carefully because most of the time a mock is what you want because it has a lot of benefits. However, there are times when you just need a fully configured real object, and this is where stubs come into play. A big problem for us is asynchronous operations. We as iOS developers often wait for long-running tasks to happen. We dispatch something to an NS operation, to GCD, to whatever. Kiwi gives us a nice macro, which is called expect future value together with should eventually. Expect future value just abstracts a value and makes it possible to check it again and again and again. And should eventually just pulse on a loop every, I think, 0.1 seconds if the if it's true. You can even specify the timeout. The default is 1 second, which might not be enough for very slow operations. So we can say, okay, should eventually before timing out after 10 seconds. Another thing is network request stubbing. As I've said, unit tests should mock everything that is outside of the system under test, which is necessary to make unit tests stable, reliable, work offline, whatever. Just they shouldn't depend on something else. For that reason, we don't want to run unit tests against a real web server. We probably don't even want them to go against a staging or whatever, or local web server. So we need to stop the network requests, just like we stopped an NS object, we can stop the network response. There's a great library called OH-HTTP stubs, which makes it very easy. The idea is pretty simple. It's a custom NSURL protocol that intercepts all network calls and is able to return custom response data. It's pretty easy to use. First, we can define which HTTP calls exactly we want to intercept. As you can see in this block, we return a Boolean, but we can fully check the request that's going out to the web and check if we want to intercept it and give a custom response. Next, we create a custom OH-HTTP stubs response that will be returned to whoever is calling. You can build response objects with NS data, response codes, custom headers, or as you see here, even custom files. If you want to test different network scenarios, which should be pretty important, you can either supply a fixed response time or a download speed like Edge, 3G, Wi-Fi, or just a custom value. When supplying a download speed value, the response time is calculated from the speed and the size of your response. So you can pretty accurately mock a 3G download of whatever. So let's combine it into one, asynchronous networking. It's like what we're doing all day, I think. So we can see here, we've got a task that we want to send to the server. We make a HTTP post call to tasks.json, which you see in line 4 is equal to string tasks.json. So our HTTP stubs intercepts the call and responds with a file to do create.json after waiting for 1 second. And you see in the main it block that we're waiting 3 seconds until the value has been reached that we wanted. Effectively, the response from the server has been parsed. This makes it very easy to work reliable with networking. Another thing is core data. Testing core data managed object models is basically great, but it needs a little trick when setting up the managed object context. First, we need to set up the managed object model. The trick is that unit tests don't run on the main bundle. They use a custom unit testing bundle, so which obviously does not contain our managed object model file. So we need to pass in a class that is in the same bundle as the managed object model. Most of the time, you can just use your model class, like, I don't know, task class, and get the bundle from there. Then we set up the persistent store coordinator with an in-memory store persistent store. This, obviously, you have to do it a lot of times. So we've open sourced this. It's not a lot of code, but we've broken it down to one line, which you can find on GitHub. If you're using Magical Record already, it does have similar functionality, but Magical Record is another topic, I think. Similarly, the same problem appears when testing view controllers or window controllers. As I said, the unit tests don't use the main bundle, so it won't work with the, it won't find the nips or dips by default. For that reason, we need to initialize the view controller with the correct path to the resource or the correct bundle on iOS. The great thing is you can use this technique in all your view controllers by default because it doesn't break anything. It just works normally plus in unit tests. So you should definitely think about adopting something like that. Yeah, as I said, Apple is not a big fan of unit testing. So if you're doing test-driven development, you'll probably want to use a continuous integration server like Jenkins or whatever. Yeah, for that reason, you need to be able to run the unit tests from the command line. Apple differentiates between logic tests and application tests. Logic tests is mostly your model objects, but application tests is everything that relies on iOS frameworks like UIKit, so every view controller, and whatnot. In recent times, people have switched away from differentiating it and just saying, okay, we want to write tests, right? We don't care if it uses UIKit or not. I want to know if it works. Yeah. Luckily, Stuart Gledo thought so too and wrote a tool called Xcode Test, which allows you to use logic tests as well as application tests or whatever tests from the command line. It's a bit hacky. You see, it's just a script you use in your build phase or on your Jenkins or wherever. But it works great, and it's definitely an improvement to all the other techniques around where you modify Apple's code and stuff like that. All right. Originally, I wanted to do a quick demo, but I think we're running out of time. Yes, we are. So I want to do a quick discussion. A very important thing about test-driven development is most people that start with it aim for 100% test coverage, want to test everything, and yeah, just generally try to do it to the extreme. So who of you, raise your hands please, has done test-driven development before? Okay, who thinks you should have more than 50% test coverage? And more than 80%? Okay, there's two people. So it's a pretty big discussion. I think counting a number of lines for tests is not getting us anywhere, because most of the time it's coming from your CTO or whoever is saying we need to achieve 70%, 80%. It's in the contract, but you could just write tests that call your code and execute a lot of it, but you don't get any benefit from it. So think about what do you want to test, and I think you should focus on critical parts that are either very fragile, because they're old, because they're complex, because of whatever reason, or are business critical. Like check your model objects, check your parsing, check the interoperability, but don't test if a view is red if you're just assigned it to be red. I don't think you don't need to do that. So now go forth and test. Thank you. All right, questions?
Hi. So you recommend to run the unit tests on every build? Is that?
Exactly.
Yeah, okay. But what about the asynchronous tests that take 3 seconds? I mean, then like.
Right. They shouldn't take 2 seconds. It's an extreme example. I mean, most of the time when we're doing unit tests and we can control the speed of the response, it's 0.1 second or whatever. What I personally do is I run the unit tests for the class that I'm working on every time I build. And I run the full set of unit tests on the continuous integration server, which makes a build whenever I push to our repository. So I think you should test a lot and very frequently the stuff that you're working on, and have a big test pool that might take a minute or two to run on your continuous integration server.
I just wanted to hook into that for a second. So as far as I know, you can only run either all tests or none of them. So I'm talking about extra.
You can do that. You can go. I can show you that. So you've seen it. You can go to your scheme, and then you can tick which tests you're gonna. Oh, I'm sorry. So I'm gonna do the steps again. Let's go to our scheme at the top, edit scheme, and when you go to the test section, you can tick which tests to run. You can deselect them and there won't be a run.
But is there a better way to do that instead of going to that screen every time I change what I'm working on, or is that the only way to do it?
Pardon, I didn't get that.
Is there a way to make it somehow context aware so that if I'm in file X and I'm changing that, it automatically turns that on?
I hope there will be. I think AppCode does that, but I've never used it. So yeah, as I said, Apple is not very interested in improving that, but maybe we get a plugin someday that does that.
Hey, in the Ruby world, there are like things like Kicker or Watcher, which observe the file system for changes in files. Is there anything like that already in Objective-C world?
I didn't get it.
Like coming from like having a small Ruby background,
yeah.
I know tools like Kicker or Watcher, which observe the file system for changes in files and then automatically can run tests.
Yeah.
Are things like that already coming up in the Objective-C world?
Okay. I don't know. There would be a great thing, I think, but I don't know if it's possible yet.
Okay, thanks.
Just a small comment on the thing you showed about testing with core data. You suggested to use an in-memory store, and I also did it on the last project, and afterwards I ran into a bit of trouble because it behaves, in-memory store behaves a bit different with the concurrency and threading stuff compared to the SQL store.
Yeah.
And I had at some points I accessed some variables not in the correct thread and so, or not in the correct queue, and run into trouble. So I think it's better to use an SQL store there, and then you can also apply in the scheme an app bundle with just an empty app bundle and use this for testing. So then each time you start the test, the data are cleaned, so you have a clean state, and you have the same effect with it.
Okay, yeah, cool. Well, I've never had this scenario where I needed something else than an in-memory store, like the difference. But it's good to know.